Okay, so here's a recording of the end of the lecture for March 16th, Wednesday. Particularly in the first section, the 8 o'clock section, I didn't quite finish the lecture, so this is basically the rest of it. Okay, so I talked about the trigonometric functions that involved pi over 2 minus t and pi over 2 plus t. So we have the sine of pi over 2 plus t. If we use the angle addition formula, we get the sine pi over 2 times the cosine of t plus the cosine pi over 2 and the sine of t. And of course the cosine of pi over 2 is going to be 0, and the sine of pi over 2 equals 1, and so when all that reduces down we get the cosine of t. Now if we do something similar to that with the cosine, we have the cosine of pi over 2 plus t, and same kind of expansion using the cosine formula, and the fact that the cosine of pi over 2 is 0 and the sine of pi over 2 is 1, we actually get negative sine of t. And as I recall this morning, we saw that that was going to be the sine of t, and actually that's incorrect. It's the negative sine of t. So if we look at the other two now, the ones with pi over 2 minus t, the sine of that, following a similar kind of analysis where the sine of pi over 2 is 1 and the cosine of pi over 2 is 0, we end up with the cosine of t, and then similarly with the cosine of pi over 2 minus t we get the sine of t. So what's relevant about that is that these last two ones are important, where we can take the sine of the difference between those two things as the cosine, and the cosine of pi over 2 minus t is the sine of t. So we're going to use that in calculating the derivative of the cosine. Okay, so I went through a rather lengthy discussion on deriving why the sine of x is, or the derivative of the sine of x is the cosine of x. What I didn't get to was the fact that we can use those previous identities to calculate the derivative of the cosine of x. So basically, if we make a substitution where the cosine of x equals the sine of pi over 2 minus x, and then rather than using the expansion like we did before, let's use a chain rule here to decide, see if we can compute this. And so the chain rule then says we have an outer function, so the derivative of sine is cosine, and we keep the inner function, which is pi over 2 minus x, and then we multiply it by the derivative of the inner function. Well, the derivative of pi over 2 is 0. Derivative of negative x is just negative 1, and so we get that negative 1 on the outside. Now we notice that the cosine of pi over 2 minus x is the sine, and so we have still that times negative 1, and so what we get is the derivative of the cosine of x equals negative sine of x. Okay, so let's go through a series here where if we have a function, the sine of x, and we take the derivative, we get the cosine. If we take the derivative again, we're going to get the negative sine, so that's the second derivative. Third derivative, or just if we have a function negative sine of x, the derivative of that is going to be negative cosine. And finally, the fourth derivative, we get back to the sine. And so this is cyclical. We can keep on taking the derivatives. And of course, if we go back the other direction, if we go back in this direction, of course, we're taking the antiderivative. So those four expressions, I think if you keep track of the fact that the derivative of the cosine is negative sine, you can kind of reconstruct this at will. Okay, so this is the homework that's due for March 15th. Of course, I want you to know that the derivative of the sine is the cosine, and the derivative of the cosine is the negative sine. And so the work then is, I want you to take the derivatives of the tangent, the cotangent, secant, and the cosecant. Now these are fairly straightforward derivatives, and very often you're asked to memorize these, and I've always found that it's better if you just learn how to derive them on the spot. So the way that you go about doing this, and this is a big hint here, is that you want to change the function using just sine and cosine, and then use the quotient rule. So for example, with the derivative of the tangent of x, take the derivative of the sine of x over cosine of x, and then when you apply that ratio to the quotient rule, you'll get something of this form, where you have, you know, the product of two things minus the product of two other things divided by the square of one of the functions in the denominator. So I'll let you work through all those. Remember that with a secant and cosecant, those are reciprocals of sine and cosine. So when you're using the quotient rule, remember that in this first spot that you get here, that's going to be essentially the derivative of 1, which is 0. So make sure that that you do that properly. And so getting those four derivatives is probably the most meaningful thing I can think of that you do at this point. So we'll talk again on Friday.